In this problem, we want to determine the magnitude and the direction of the resultant force. So I have two forces here. F1 is 250 pounds, heading upward at a 30-degree angle from the vertical, and I have F2 of 375 pounds, heading downward 45 angle from the horizontal. Okay, so what I need to do is I need to create my parallelogram. Okay, to do that, I just draw my forces, F1 and F2, and then I draw parallel lines. Okay, so this line is parallel to F1, this line is parallel to F2, and then I draw my resultant force across the diagonal like so. So what I have here is a triangle here that I can then use to solve for that resultant force. So this side of the triangle is F2, so the magnitude of this side is 375. The magnitude of this side of the triangle is 250. Okay, I know that this angle is 75 degrees, and I know that because of the 45-degree angle and the 30-degree angle. So if I had like a vertical line in here, going that way from the vertical line is 45 degrees, alternate interior angles, and then from here to here is 30 degrees. Because that's the direction of F1. So I know 75 degrees, I know this side is 375, and I know this side is 250. So what I do in order to find the opposite side, I use the law of cosines, which is given here. So it's the square root of each side minus 2 times each side times the cosine of the angle between them. So I have the 250 squared plus 375 squared times 2 times 250 times 3 times 375 times the cosine of 75 degrees. That gives me the length or the magnitude of this side, which is my resultant force, to be 393 pounds. Okay? So that gives me the magnitude that I'm looking for. In order to find the direction, I need to find essentially this angle theta, and then from that I can back out the angle relative to the x-axis. Okay, to do that, I use the law of sines, which is 75 times, sine of 75 divided by the opposite side, or the reciprocal of that. So it's this side divided by the sine of 75 times this side, which is 250, divided by the sine of theta, which is given here. Okay. Solving for theta here, I get 37.89. Now, to put this relative to the x-axis, it's basically going to be, I can use this 45-degree angle to find that, from here to here is going to be 45 plus 37.89, excuse me, and then back out that angle. Okay, they're doing this from the positive x-axis, so it's this whole angle right here. So it's going to be basically 270 plus 45 plus theta gives me that. Or as they have it here, 360 minus 45, like that. The other way I could think about this is it's a minus 7 degrees. Okay, so either angle will be fine. It just depends on how you're defining it. Okay, so again, set up your parallelogram. Determine all the angles and sides that you know in your triangle, then use the law of sines and cosines to solve the problem.